Let's take a look at lesson 10.4, which is solving radical equations. So let's really quick review some of the equations that we've solved first semester as well as this semester. So first semester and even last year, you did a bunch of what we call linear equations. So that's what this first one is. 2x minus 7 equals 13. Your goal is to solve for x. So remember, I have two numbers on the same side as x. We want to move them to the other side. You move numbers that are not connected first. The opposite of a negative 7 is a positive 7. So I add that. It gives me then a 2x to equal 13 plus 7 is 20. I'll divide both sides by 2, and that gives you the x by itself. 20 divided by 2 is 10, so 10 is my answer. The second problem here is something that we did back in chapter 9 of this semester. So notice that 3x squared plus 10 equals 85. Want to start off the same way as we did with the last problem. There's two numbers on the same side as the variable. We got to get the variable by itself. Move numbers that are not attached. So that means I'm going to subtract the 10. That gives me then a 3x squared to equal 75. We'll divide both sides by 3 to get the x squared by itself. 75 divided by 3 is 25. But now this is not my final answer. Because it is a square, we have to think back to chapter 9. How do you get rid of a square? We want to take the square root. So if you do the square root to one side, you do it to the other. What you also have to remember is because that exponent is a 2, we technically have two answers. We have both a positive as well as a negative. Square root of 25 is 5, so both positive and negative 5 are my answers. So notice once again, in the first one, exponent is a 1, which is why my answer has one answer. In problem number 2, my exponent is a 2, which is why I had two answers. So whatever your biggest exponent is tells you how many answers you should have. All right, let's move into then what today's lesson is all about. It is where we are starting with a radical in the equation we want to solve. It also says in the directions, we want to check the solution. That's going to be super important, and we want to get into the habit of, yes, we get an answer, but is that answer truly the answer? Sometimes it will, but sometimes it won't. So checking the solution is going to help you with that. So if we take a look at the first one, the square root of x plus 7 equals 16. Because the 7 is not underneath the square root, I have to move that 7 to the other side by subtracting. That then gives us the square root of x by itself, and 16 minus 7 is going to give us 9. Now I want to get rid of the square root because we've isolated that by itself. Well, if you go back to that problem that we just did right above in problem number 2, we started with an x squared, and to get rid of a square, we took the square root. Well, what we're doing now is we're starting with a square root. So to get rid of a square root, we're going to do the opposite. We are going to square it. So I'm taking that whole entire left side and squaring it, which means I'm taking the whole entire right side and squaring that as well. Squaring a square root is going to give you just the x by itself. Remember, 9 squared is the same thing as 9 times 9. That is 81. But I'm not just circling my answer until I've gone back and checked my answer. I want you to show your work for how you're checking. So essentially, I'm taking the number that we think is our answer, which is 81, and I want to plug it back into the x in the original problem. So under the square root, I want to plug in 81. Then I want to add 7, and I want to know, is that really going to equal 16? So you can use your calculator, but I want to focus on, does the left side, when I simplify, turn into the right side? So in the calculator, if you take the square root of 81, you're going to get 9. If I add 9 and 7, I want to try to get 16. Well, lucky for us, we do. And so because we get the two numbers to be the same, that means that 81 will be the answer, so I can circle it. In the second example, start off with the same thing. We have a square root of x minus 5 equals negative 2. Numbers that are outside of the radical need to be moved to the other side so we can get that radical by itself. Because we start with a negative 5, we want to do the opposite. We're going to add. That then gives us the square root of x by itself. On the right side, negative 2 plus 5 is 3. To get rid of a square root, remember, I want to take that and I want to square it. If I do it to one side, I'm doing it to the other. Squaring that square root is going to just give us the x that I want. 3 squared is really 3 times 3, and that's 9. So remember, I can't circle that until I've gone back and checked my work. So I'm going to substitute 9 back into the x in the original problem. So we'll have the square root of 9 minus 5, and I want to know, does that really equal negative 2? Well, in the calculator, the square root of 9 is 3. So is 3 minus 5 going to get us negative 2? And once again, if you use your calculator, you should be able to see that yes, it does. And so because that is the case, I can circle my answer. If I wasn't getting the same number, then I wouldn't be able to circle my answer. I would have no solution. Let's move on to the second type of radical equations that you have. Here, I have 2 square roots. In the first examples that we did, there was only 1 square root, and so we isolated by itself. Well, now if there's a square root on either side, my goal is to get rid of that square root first. Just like the last problems above, what we do to get rid of a square root is we square. So I'm taking the entire left side and I'm squaring it. That's going to equal then the entire right side being squared as well, because what you do to one side, you got to do to the other. So when I square a square root, that is just going to leave you with what was underneath that radical. So on the left, it's 5x minus 11. On the right side, it would leave us with x plus 5. Now I've got variables on both sides, but my goal is to solve for x. So I want to move one of the x's. It really doesn't matter which one we move. I think I'm going to move the x, which is technically with a positive 1 in front. To move it to the other side, I'm going to subtract it. That would then give us a 4x minus 11, and now that just equals 5. Now I have the x on one side. My goal is to get the x completely alone. With the 2 numbers on the same side, we're going to move that 11 first by adding. That would then give me 4x to equal 16. And then my last step would be to divide both sides by 4. And so my potential answer is that x equals 4. But in order for me to say that that is confidently my final answer, we have to check our solutions. Because notice that directions up here, check your solution. So I'm looking for that work in your homework, on a quiz, on a test. So I go back up to the original problem. This time there is an x not once but twice. So I'm going to be replacing x with 4 on both sides. So under the square root on the left, we will have 5 times 4 minus 11 under that square root. On the right side, under the square root, we will have 4 plus 5. So I just want to make sure, does the left side under the square root match the right side? So I'm going to focus on the numbers under the square root. 5 times 4 is 20. I want to know, if I subtract 11, what am I going to get? Well, 20 minus 11 would give me 9. So you can leave it as the square root of 9. If you were typing all of that into the calculator, it would probably spit out the number 3. On the other side, notice that 4 plus 5 is what I wanted to add, and that gives me 9 under that square root, which once again, if you were to type all of that into the calculator, it would spit out the number 3. So notice that both sides, I do get the same number, regardless if I keep it as a radical or if it turns into then that nice number of 3. So that tells us that x does equal 4. We can circle it. That's our final answer. So then in problem number 4, same thing. Because there's square roots on both sides, I'm going to take the square root of 7x minus 4 and I'm going to square it. I get to do that to the other side as well. So the square root of 5x plus 10 is going to be squared. So when you square a square root, it just turns out to be what was underneath the square root on both sides. So now we have the equation 7x minus 4 equals 5x plus 10. With variables on both sides, I want to get all of the x's to one side. It doesn't matter what side you move. I think I'm going to move the smaller x. So the 5 is smaller than the 7. So I'm going to take that 5, and the opposite would be to subtract. So I'm going to subtract that over to the other side. That gives us then 2x minus 4, and now on the right, it just equals 10. Several numbers on the side is x, so I'm going to move that 4 by adding. That gives us 2x to equal now 14. And then I'll divide both sides by 2. And so my potential answer is that x equals 7. Remember, we have to check our solution. So I'm going to see that I've got several x's. So there's 2 different spots in this equation where I want to plug in 7 and see if the left side equals the right side. So under the square root on the left, I want 7 times 7 minus 4. On the right side, I want 5 times 7 plus 10. Okay, now if you put this into the calculator and just focus on the left side, it might give you a decimal, and that's okay. If you then do the right side, you're looking then for the exact same decimal to know that you have the correct answer. So once again, just make sure you're showing me what it is that you're going to be typing into the calculator. But for me, I'm going to show you the step-by-step process. So I would multiply the 7 and the 7 to get 49. And then I would want to subtract 4 from it and keep it under the square root. 49 minus 4 is 45. So that's what I'm looking for on the other side. We'll notice that if I multiply the 5 and the 7 on the other side, we get 35 plus 10 under the square root. Well, 35 plus 10 is going to be 45. They're both under the square root. It's the same number under the square root. That means that this 7 is my solution, so I can circle it. If you turn to the next page, you'll see a couple of checkpoint problems. So please pause the video and try those 2 checkpoint problems and make sure you are checking your solution. Okay, so hopefully you did that. Here are the answers to the checkpoint. So notice that in the first one, we had to isolate the square root by itself, by subtracting the 11 and then squaring both sides. But I didn't technically circle that 100 until I've checked my work below. So notice that I substituted the 100 back into the square root. Taking the square root of 100, you get 10, and 10 plus 11 does get you 21. So that's why I was able to circle 100. In the second example, I had to square both sides. So that just left me with what was underneath the radicals. I then added the x, added the 13, divided by 4, and my potential answer was 5. So notice that I substituted 5 into both sides of the original problem. I ended up then getting the square root of 2 on both sides, which is why we then have our final answer, x does equal 5. Please reach out if you have any questions as you're going through the homework.